Alright, this is going to be a really short video. It's about something called the Henderson Hasselbalch equation for calculating buffer pH. It's a very simple, short and sweet method for doing so. In the previous video I showed you several things about how buffers work, and then we went through an ice table calculation to figure out the pH of a buffer, where we had concentration here and a non-zero concentration here, and we went through to figure out how the pH got to be what it was. And we'd said that the pH of acetic acid, 0.1 molar acetic acid, was 2.9, and we'd also said that the pH of the buffer of 0.1 molar acetic acid and 0.1 molar acetate was actually 4.74, so less acidic, as we expected. What I'm going to show you is we can get the pH using this, which is the Henderson-Hasselbalch equation, in a much less painless way. Alright? Now this works if these two concentrations are the same, it works if they're different. It won't work if one of them is zero, because then you don't have a buffer. The only thing is, this has to be a buffer that you're talking about, so you've got to have a weak acid and its conjugate base. So you can't have, say, this and then F minus, or this and then, Br minus, or something like that. Anyway, here's all the information you need: the concentration of the acid, the concentration of the conjugate base, and the Ka. What you're looking for, of course, is the pH. So the pH is equal to the pKa of the acid plus the log of the base, the conjugate base, the concentration of the conjugate base, over the concentration of the acid, and that's the log of everything here. Okay? So the only thing that we don't have at this point is the pKa, but we do have the Ka. And I'm sure you remember that pKa, just like pH, is equal to the negative log of the Ka. And when we do that, what we get is 4.74. Now we aren't done yet. So pH is equal to, in this case, 4.74 plus the log of the conjugate base concentration, which is 0.1 molar, over the acid concentration, which is also 0.1 molar. Now remember what happens when you take the log of 1, because 0.1 divided by 0.1 is, of course, 1. What's the log of 1? Well, of course, the log of 1 is 0. So therefore what that means is the pH is equal to 4.74 plus 0. Let's forget that. The pH of your buffer is 4.74, exactly what we just set up here. So what you find is, for every buffer that you come across, you can calculate the pH two ways. One, using the ice table. Two, using the Henderson-Hasselbalch equation. One thing I always get used to doing is calling this the Henderson-Hasselbalch equation, because I guess I'm enamored with David Hasselhoff. I don't know. Although he was pretty cool in Knight Rider, I suppose, for those of you that remember it. For those of you that don't, he's not really very cool anymore. So yeah, if you call it the Henderson-Hasselbalch equation, then fine, it's a nice simple way to remember it. But anyway, the point is, whichever way you calculate your buffer pH, you get to the same answer. This tells you that you are doing things right. So the Henderson-Hasselbalch equation is a good way to figure out the pH of a buffer without too much pain. Alright, that's it.